Are we okay with this? Okay.
Yeah. We are good, Candy.
I'm sorry?
So we're good.
Very good. Oh, sorry, I don't mean to look down on you or anything. I just wanted to make sure that we understand. We start with reviewing that. Oh, now the skills assessment. I will do whatever you want me to do from here. You decide. If you say I know it all, then we'll start chapter 2. If you say, no, I don't know it all, or I do know it all, but I want to see it. Whatever you want from here. So I'm going to read them one by one, and you say yay or nay. So the first problem, because you're going to have to turn this in on Saturday. In WebAssign will give you different questions. You're going to write this down and turn in the solutions. Okay? So you have to submit the assignment in the module for the skills assessment and others. And you have to submit your work, your answers in WebAssign. So 2 things need to happen on Saturday. This will be uploaded, your written work, uploaded in the module in Canvas. And the answers also in WebAssign by Saturday evening, September the 5th. Any questions? Okay, so find an equation for the line that passes through the given point and is parallel or both. Cannot happen, but first parallel and then perpendicular to the given line. So please tell me whether I need to show this. If you say yes, I'll show it. If you say no, I'll move on.
I just have a quick clarification question. Do they want both parallel and perpendicular?
Yes, I think WebAssign will ask you for both, or if it asks you for just one, then just one.
Okay, sounds good.
So yes, go ahead.
I said, can we go over it?
Yes.
Also, it can't really see it, so like, can you rewrite it? The equation.
Yeah, it's hard to see it.
Open it in Canvas. Open the skills assessment in Canvas.
Okay.
So I'll wait for a minute for you to open it in Canvas so you can have it in front of you. It's the same one. I just printed it out from there. Just download it and save it somewhere or not. Just open it and you'll see each problem. Thank you. Actually, I should have said that myself. Everyone okay?
So this skills assessment, if we print it out, is that what you want?
No, you should not print it out. You should just present the solutions for the one you will get in WebAssign. Everyone will get a different one. So do not, that's why I didn't want you to print out this. This is the one that WebAssign gave me. But everyone will be different, slightly different. So don't print it out, just have it pulled up so so we can follow through. Everyone ready? So do we still need to talk about number 1?
Yeah, I'm down.
You said yes? Somebody said yes?
Yes.
Okay.
Yes.
So the first one is 2x minus 3y equals 4, and the point is negative 2, 3. Would you like to do the parallel or the perpendicular?
Let's go perpendicular.
Very good.
I was going to say parallel, all right.
Parallel lines, so M1 equals M2 for parallel, and M1 multiplied by M2 equals negative 1 for perpendicular. It's something that you remember as M1 being negative 1 over M2. It's much easier to remember that the product is negative 1, but it's up to you. Don't change something that works. If it works, keep it that way. Unless it's easier and you understand this is the same thing. So we are asked to determine the equation of a line. You can see this, right? That there is no problem. You cannot just see this, but this is clear, right? Okay. Good. So here we have a line. We know two things about it. That somewhere along the line we have this point. And we also know that it's perpendicular to a given line. Perpendicular means 4 90-degree angles to a line whose equation is 2x minus 3y equals 4. Okay, so I'm hoping that somebody will give us the point slope form for the equation of a line. Anyone remembers the point slope form for the equation of a line?
Y equals mx plus b.
That is a good one, but it's not the point slope form. So this is the slope.
I'm sorry.
That's okay. It's very good that you refreshed. We need to discuss this anyway. So slope y-intercept form. Yes, go ahead.
Is it y equals, no. Would it be f of x is equal to, oh yeah, that. Never mind.
That's okay. So y minus y1 equals a slope times x minus x1. And we do have the point. The point is given to us as x1, y1. So that is -2 and this is +3. The only thing we're missing is the slope. But we do know how to determine the slope. Because the lines are perpendicular, if I determine the slope of the green line indirectly, in other words, from there I will directly determine the slope of the blue line. But how do I determine the slope of this line? And that's where I was going to ask you about the slope-intercept form, but you already gave it to me. So the key is... Go ahead.
No, I just said sorry.
No, I needed this. So anyway, if you see, this equation really is solved for y. If the equation is solved for y, then this will be its slope. All I have to do is solve the equation that I was given for y in order to identify the number in front of x. The number in front of x, or the leading coefficient, if you want, will be the slope. How do I solve this for y? Well, obviously I have -3y. I move 2x to the other side. As a refresher, when I want to move one term from one side to the other, all I have to do is just change its sign. And the final step is I have to divide by -3. It will not be a mistake to do this and write -3, but it will be difficult to read. So divide by -3, step by step, term by term. So when I divide by -3, I get y, I get 2/3 x, and I get -4/3. So therefore, the given line has a slope, as you see by comparison right here. Just look at mx and of slope of 2/3. Well, if any of these two is 2/3, it doesn't matter which one. If you want to say this is 2/3, how much should this be for the answer, the product, to be -1? So if this is 2/3, multiplied by what will equal -1? And that's the slope of the other line. So what is the slope of the other line?
Negative reciprocal.
Oh, negative reciprocal, of course. -3/2, of course. There is no other number. Only 2/3 times -3/2 will equal -1. So therefore, this is -3/2. So it's not enough. I have to solve for y, I have to plug in all the numbers, and I have to finish it up and get y by itself. Any questions before we do that? Any questions before we do that? Okay, so then I copy y minus 3. I copy negative 3 halves. I copy x plus 2. That's why I wrote it here, because I don't want parentheses inside parentheses, nested parentheses. I don't like that. So the opposite of negative 2 is positive, and y minus 3. And then I have to distribute negative 3 halves. I have to multiply negative 3 halves by 2, and I get negative 3. And I have to move negative 3 to the other side by adding 3. So it turns out that the equation of the unknown line that passes through the point negative 2 comma 3 and is perpendicular to the given line 2x minus 3y equals 4 is y equals negative 3 halves x. This is a very important type of problem moving forward, because we are going to be asked to determine the equation of the tangent line to the graph of a function throughout the entire course. Any questions? Any questions?
No.
If I move too fast, or if I move the pages too fast or something, or put them away, just let me know and I'll go back. Okay, I don't think we have any difficulties in number 2, but let me know. Just read number 2, the graph. We're given a graph. We're asked to find f of 1, f of negative 1. Find the x values for which f of x is negative. Oh, it's 1. It's 1. Estimate the values of x for f of x being 0. State the domain and range, intervals of increasing, decreasing, and the y-intercept. Yes, no, any of this? Anyone?
No.
Okay. Moving on to find the domain. I already created a problem similar to this that you're going to work on in the next few minutes. After I finish this, it's your turn to work on a problem. We're going to open that assessment and we're going to start working on it. So please pay attention to what I'm doing here. So we are asked to find the domain of this function. Okay, any questions here or any suggestions? Is there anything that you will recommend? How do I start? What are potential problems here? What do I need to do?
Start by finding the variables in which the denominator equals 0.
In other words, you're telling me that x plus 5 cannot be 0. Is that okay?
Correct.
Perfect. Excellent. Next. Is there anything else?
Didn't you rewrite the top function to x squared, or sorry, x minus 2 squared? Yeah. Isn't it one of the...
Special products.
Yeah, sorry, special products.
But it's not 3 terms. It's this one.
Yes, sorry,
with
that's
2
what I
terms.
mean.
Okay, very good. Very good. But before we do that, what do I need to do? What conditions?
I was going to say set the bottom equals 0 first.
The bottom, the denominator cannot be 0. But is there any other condition that needs to be complied with here?
X cannot be less than 0.
No.
Oh, the solution under the square root cannot be negative.
Very good. Oh, what is this? X squared minus 4 has to be greater than or equal to 0. So let me refresh your memory. Thank you very much. When you speak, it would be great if you would tell me your first name, so or the way you want me to call you, so that I know who answered. That's awesome. If you want to do that, that would be great. Good. So when we talk about even index, this number is even, meaning 2, 4, 6, 8, etc. The quantity under the square root or the fourth root or the 10th root, etc., must be positive or 0. Now, if I have something like this, the domain of this function will not be this, because the square root is in the denominator, will be this. Okay? But we're talking about a quantity that has a square root and is in the numerator. So this is x squared minus 4. So there are two...
What's the difference between the equation or the anything that you crossed out and the one that you rewrote? Because in the first one that you crossed out, you wrote x is greater than 0, and in the second one is also x is greater than 0. Is that like a mistake, or?
The way, because I crossed it out.
Yeah, no, it looks like they're the same equation. And they're not, and what's the difference between those
So
two?
no, this is an example, a side example.
Yeah, no, I get that, but like for the side example, when you cross out, you wrote x is greater than 0, it's the same as the one you wrote underneath it. Or that's supposed to be x is greater than or equal to 0. I'm just trying to right here.
This one you mean?
Yes.
Okay, now I can hear you. For some reason I couldn't hear you before. So
Oh,
I said for something like this, because when the square root is in the denominator, I cannot write x greater than or equal to 0 because it's in the denominator. So the domain of this function will be x greater than 0.
Gotcha. I didn't see the greater than or equal to. It just
Yeah,
looked like greater
that's
than.
why I crossed it out. I wrote initially greater than or equal to 0 because I wanted to cross it out and say if the square root is in the denominator, x cannot be 0.
Gotcha. Thank you.
Thank you. Now, the first condition, so these are both conditions. As you see, I put them together with this symbol. Normally, this symbol is used for systems. Both conditions have to be fulfilled in order for us to be able to determine the domain of function f. The first condition is very easy. X cannot be negative 5. The second condition, be very careful. You cannot move forward to the other side and take square roots. Do not do that. It's not allowed. Impossible. Don't even try it. Yes, we have to start by factoring x squared minus 4, which indeed is x minus 2 and x plus 2, which has to be greater than or equal to 0. And here we have several options. One option, which I really don't care for, but it's fine, I can graph. I can graph this. I know the function is a quadratic function. I know it opens up because the leading coefficient is positive. I know it crosses at negative 2 and positive 2. And I know it also crosses at negative 4. That's very easy. I don't want to do this because in this situation it is not a difficult graph. It's x squared minus 4, but in other situations I'm not going to waste my time graphing because other methods are much easier. So what does this say to me? This says that if I pick x between negative 2 and 2, if I pick x between negative 2 and 2, the function values are below the x-axis. So this is a negative situation. If I pick x to the right of 2 or to the left of negative 2, the function values are positive. And that's the answer for this. Meaning, when is this expression greater than or equal to 0? Well, to the right of 2 or to the left of negative 2. So now the conditions are x not equal negative 5, and x in the interval negative infinity to negative 2 union 2 to infinity. And what does this tell me? Well, again, it is is very easy to explain on the real line, where I have 0 in the middle. If you don't stop me, if you fall behind, I will not know. So I rely on you. So -2 on this side, 2 on this side. So this is -2 to negative infinity to -2, and this is 2 to infinity. And this tells me, make sure you remove -5. As you notice, I don't care for units. This is just to explain what the domain is all about. So that the domain of function f must be -infinity, -5 with a parenthesis, union with a parenthesis again, -5 to -2, bracket, union, bracket, 2 to infinity. So this is the domain, but I want to show you the other method of solving a quadratic inequality. This is called quadratic inequality. How did we solve it? We just graphed it. And we realized that for any x value between these two, the function value is below, so it must be negative value. The product will be negative. To the right, if I pick 2, to the right of 2, or to the left of -2, the product will be positive. And that's what I want. So here's another way, which I consider more elegant. No one stopped me, so I move on. Yes? No? Well, I really hope that at least someone is listening. I hope. Okay. So here's another way. I'm going to remove this. If you still need it, you'll let me know. Okay, so here's another option which I like very much. This is a table of values used to study the sign of a product or ratio. Oops. So this table cannot study the sign of anything else but a product or a ratio. Product of factors, ratio of factors. And here is how we do it. The first factor, x is the value or the variable in the problem. So the variable in the problem can go from anything to anything. X minus 2 is the first factor. Of course, x plus 2 will be the next factor. And what I'm really interested is in the product. That's what I want. I don't care for this, I don't care for that, I care for the product. Okay, so I need to find where each factor is 0. Well, that's very clear. This will be 0 for 2. This will be 0 for -2. I have to put them in ascending order. -2 is first and 2 follows. -2 is for x plus 2, where it's 0. X minus 2 under 2 will be 0. And of course, if either one is 0, under -2, the product will be 0, and the product will be 0. Extremely useful and helpful to remember how to graph something like this. I don't really have to graph it. This is the easiest possible function. Both of them look like this because they have a positive slope. 1, 1, 1, 1. So they come from -infinity and go to +infinity. If either one has a negative slope, then it will come from +infinity and go to -infinity. but both of them have a positive slope. All I have to do is copy the sequence. Again, how do I know the signs? Because x minus 2 looks like this, from negative. It crosses the x-axis at 2 and goes to positive. This one, it comes from negative values. It crosses the x-axis at negative 2, and then it's above the x-axis, which is positive. And now I see 3 subintervals. On the first subinterval, I have a product of 2 negative numbers. Well, that cannot be anything but positive. In the second subinterval, I have a negative and a positive. Well, it must be negative. And on the last subinterval, I have a product of 2 positive numbers. Well, it must be positive. And that's how we arrive to this. Positive, because that's what the sign is telling me. It says choose x values that make the product positive between negative infinity and negative 2, and between 2 and infinity. Negative infinity and negative 2, and 2 and infinity. So this is simply another way, much more elegant way in a way. I strongly believe that. Also, it can be applied for complicated functions. That graphing will take a long time. You could use a graphing calculator. Yes, go ahead.
Could you have also taken these, split them up, solved for 0, and said as x is approaching negative and 2, it must be greater than or equal to 0.
Yes, but the thing is, yes, for the infinities I completely agree, but how will you do it here?
Oh, right.
Excellent question. I completely agree for infinities, and we're going to do that a lot. But I have to study somewhere in between. I may have 3 or 4 zeros in there, and then what do I do?
Right.
Very good question. Thank you. Okay, so now let's open our Canvas, and you have a question like this, and I would like us to work on it for the next 5 minutes.